Good morning everyone, I am Stephanie Grace Piston, and in this video, I will be showing to you on how to prove a function, a composition function, and also an equivalence relation. Let's start by proving a function. Prove that the function j n is to n is defined by jn is equal to n over 3 as surjective. Proof, let n element of capital N. Notice that J3n is equal to 3n divided 3 is equal to n. Since 3n is the element of capital N, hence J is surjective. Now let's proceed to composition function. Show that the composition of two one-to-one functions is 1-to-1. Proof, let A, B, and C be sets and let function A is to B and B is to C be functions. Assume that F and J are one-to-one functions. We will show that G of F, A is to C is one-to-one. Suppose that A1 and A2 are elements of A, for which G of F, A sub 1 is equal to J of F, A sub 2. Then, using the definition of composition functions, J open close braces F times A sub 1 is equal to J of F, A sub 1 is equal to J of F, A sub 2 is equal to J F, A sub 2. Since J, B is to C is one-to-one function, and F, A sub 1 and F, A sub 2 are elements of B, which sent by J to same element of C, it follows that Fa sub 1 is equal to Fa sub 2 using the definition of one-to-one function. Since function F A sub B is to B is a one-to-one function and A1 and A2 are elements of A which get sent by F to the same element of B, it follows that A1 is equal to A2 using the definition of the one-to-one. Therefore, we have shown that if J of F A sub 1 is equal to J of F A sub 2, then A1 is equal to A sub 2. By definition of one-to-one, it follows that J of F is one-to-one. Lastly, let's proceed in proving an equivalence relation function. Define a relation R on the set of natural numbers n as AB, element of R, if and only if A is equal to B. Now, we will show that the relation R is a reflective, symmetric, and transitive. In reflective property, since every natural number is equal to itself, that is A is to A for all A element of capital N is equal to A is A element of R for all A element of capital N, hence R is reflective. In symmetric property, for AB element of capital N, let AB element of R is equal to A is equal to B and B is equal to A, BA element of R. Since AB are arbitrary, R is symmetric. Lastly, transitive property. For ABC element of capital N, let AB element of R and BC element of R is equal to A is equal to B and B equal to C and A is equal to C. As numbers equal to the same number are equal to one another. AC element of R. Since ABC are arbitrary, R is transitive. Since R defined on the set of natural numbers n is reflexive, symmetric, and transitive, R is an equivalence relation. Thank you for watching my video. I hope that it is clear to you in how to prove a function, a composition function, and an equivalence relation. So that's all. Thank you.